The Bourne shell script programming language supports the notion of a function. If you're already a programmer, you may know functions by a different name. You may know them as subroutines or procedures, but whatever you call them, I'm going to show you how to use them in the shell programming language. Before I do that, I just want to have a brief word about program structure. When writing a substantial shell script, and I'm talking about a shell script more than just, say, 10 lines long, you'll find that it is actually necessary to partition your program up into various segments. And so it's safe to say that most shell scripts adhere to that same structure, which looks like this. You start off with the very first line being the interpreter specification, in other words that hash, exclamation mark, and then the name of the program used to interpret the script. That's just one line. Then you typically have the opening comment. Of course this is optional, but it's a good idea to have it there to specify what the script does and how to use it. Next, you would specify all your important variables. Let's say, for example, it was a backup program, and you might have a variable that determines where the backups are actually written to. Maybe you actually don't have such a variable, but it would be a good idea to create one even if you don't. Then you would put that variable, the setting of that variable to a particular value, right up at the top of the file, such that whenever anyone opens up the file and has a look in the script, it's immediately obvious how to go about changing some of the important functionality of the script, like in this case where the backups actually get written to. This again is optional, but it cuts down substantially on maintenance, and that's always a good thing. Next, you would put any functions that you have created, and of course functions are the subject of this chapter, so that's what we'll be learning about. So when you know how to create a function, you know where to put them. And finally, the main body of code. If you're just creating a little 10-line shell script or something similar, then number 5 there is probably the only part of the shell script that you'd actually be writing. But the aim of this course is to teach you how to write substantially large shell scripts, and I'm talking about shell scripts up to, say, 1,000 lines long. So I'll show you an example of what a shell script that adheres to this structure might look like. Let's do that on the next screen. Okay, so here's the script. We start off with the interpreter line. Then we have a very simple comment. Hopefully the comment would be a little bit more descriptive than that. Then we have two important variables. One is the variable that determines the directory that's going to get backed up, and the other one is where the backups are going to get put. And notice that the next thing is actually a function. Now I'm going to be describing this in depth in the next module, but for now the programmers amongst you might just take a little moment and have a look at the structure of the declaration of a function. Notice the use of the parentheses after the word backup1 file, notice the use of the braces, the curly brackets, and notice the use of the $1, which indicates the first parameter to the function. All of these will be explained in full in the next few modules, so don't worry if that code is meaningless to you at the moment. Finally, we have the main code block, which just simply runs through each file in the given directory, checks to see that the file actually has a non-zero size, and if it does, then it calls that particular function with that particular file, which will then of course copy it to the appropriate directory and echo the fact that it has been backed up. Now in a really substantial program we would have several variables being declared at the top. We would have several functions, and some of them would be quite long, and the main block of code will also probably be quite long as well. But they would still adhere to the same general structure which you can see in front of you. So now we actually get on with the business of having a look at what a function is all about. For those amongst you that are not programmers, you would probably wanting to know what a function actually is, so let's define that first. A function is a named code block. In other words, it's a sequence of code statements that has been collectively given a name. And once you've created that code block with its name, you may actually run that code block at any point simply by invoking the code block by its name. Now that may not make any sense to you, so let's actually have a look at what it looks like. you must actually define a function before you can use it. That might sound obvious, but you actually have to have the definition of the function at a higher point in your file, in your shell script file, than the actual calls to the function. So having said that, let's have a look at the definition of a function. Firstly, you have the function name, and the rules for naming a function are exactly the same as the rules for naming a variable. So the little sample function that I've created for you just here is actually called function underscore name. Now, immediately following the word function name, or the name of the function, whatever you've called it, you put an open and closing bracket or parentheses. This signifies to the shell that what you're actually doing here is declaring a new function. The shell then expects that the line immediately following this will be an open brace or an open curly bracket. And then all the lines of code that are read in by the shell up to and including the final close curly bracket are treated as the lines of code that will get executed when the function is called. Now, it's very important. Most novice programmers have a difficult time getting their heads around this bit. The actual code that you write there inside the code block, which could be an ls or a who or any other piece of code that you might like to write, if statements, while loops and so on, that code does not get executed at all until the function gets called by its name. And if the function never gets called by its name, and it's possible that it might not, then that code never runs. So let's now have a look at how to actually call a function by its name. You must do that in the following way. You simply, and it's very simple, you just type in the actual name of the function on a line by itself, and that's it. Now suppose, for example, that you called your function, well, any old name like ABC, and then you made a call to that function from your shell script, so you just had a line in the shell script that just said ABC by itself. If someone else came in and had a look at your shell script and didn't actually notice the definition of the function in the shell script, and all they noticed was the line ABC just by itself, there would actually be no way for them to tell, just by looking at the code, whether that ABC command line was a function, or whether it was a executable file, like a shell script or a binary executable, or whether it was, say, an alias or even a shell built-in. There's actually no way to tell just by looking at the command line itself. They could have a little hunt around and find that there is actually a function declared with the name ABC, and that would obviously give them some clue. But I just wanted to stress that it's not immediately obvious just looking at the command line what that command line object actually is. Could be a function, could be a program, could be a built-in, could be an alias. Aliases actually are not supported by the Bourne shell script, but they're actually supported by the Korn shell scripts, or Bourne Again shell scripts, or C shell scripts, and so on. Anyway, it's probably time to have a look at an example of that. Here is that program that we used as an exercise from the last chapter, the one where we use grep to determine regular expression matching of the lines of a file. And I've actually created in this program a function, and the function's name is pause, and here is its definition. Now you can see the word pause, and then the open and close round brackets, then the open curly bracket and the close curly bracket are there as well. And the code block is actually just simply two lines of code, one echo and one read. Now please note that when I start this script and run it from scratch, those two lines of code do not immediately get executed. They only get executed when I call this function, and this function is called the first time down here. So the very first line of code that gets run is this one, file equals grep test, but you don't actually see any output because that's just a variable assignment. Then the next line of code that gets run is this echo down here, lines that start with a T, followed by that grep, followed by, and here's the important part, the pause. Now as soon as pause is called, the execution of code immediately jumps up to here, runs that line, then runs that line, and then jumps back out and goes down to this echo here, which will do that echo, then that grep, and then that pause, which will then jump back up to here, run that read and that echo, and then jump back out and down to here again. So theoretically, every time we run the grep, we will run the pause immediately afterwards, which should prompt us to press enter between every consecutive output of grep. So let's have a look at that actually running. Run that now. Lines that start with a T, and there's 4 of them. Then it says press enter to continue, so I do. Then I get the blank lines and another press enter to continue. Lines that have 2 or more A's anywhere in them, and there's 1 of those. And then the 2 or more digits, and then the special pattern, that's the advanced one. And then that's the end of the program. So that is a very simple demonstration of the working of one function. There's actually a little bit more to functions than that. Functions can also take parameters, just like functions in other programming languages, and functions can also return values. And again, we're going to have a look at both of those options in the next couple of modules. So in this module we learn about function parameters. I'll define a function parameter for you by saying that it's actually possible to give a function a piece of data via their command line, and those functions can then, if they want to, use that data in their processing. And the data that you specify on the command line is of course called a function parameter. Now let's do a quick recap on command lines. If I was to run the command ps, for example, which I do know happens to be an executable file, then I see the following output. I can run the ps command again, and this time I can specify a parameter, and the parameter that I'm specifying is the -f parameter, which modifies the function, the behavior of the ps program in the following way. The key words that I use then are that the -f parameter modifies the behavior of the ps program, and in the same way we're going to use function parameters in the same way that I've just demonstrated program parameters. We're going to specify them on the command line, and they will modify the functioning of the function that we specify. Let's look at an example of that. This is the example from the last module, or the one before that. Now notice that this is a function called backup_1_file, and its sole purpose in life is to copy a particular file to a backup directory and then let us know that that has actually happened. It works as you might expect any function to work, except there's one very important little addition, and that is the use of the symbol $1, which looks like a variable, and it kind of is a variable, except it's not a variable that you can actually set yourself. It's called a read-only variable in the sense that you can only read from it, you can't write to it. And what it does is it actually represents the first parameter that was passed to this particular function on the command line. So when we have a look at the command line, you'll be able to put all the pieces together and see the whole picture. So it might actually be called like this. Here we've actually called it twice. We've called it once with a file name called report.txt, and we've called it a second time with logo.gif. Each time we have specified a single parameter, which the first time is report.txt and the second time is logo.gif, and each time that that function is called, the parameter is actually copied into $1. So in the actual function, when the function runs, the very first line that runs in the function is the CP line, so it will actually read the first time CP space report.txt and then a space and then the backup dir, and then it will echo report.txt has been backed up. And then the second time it runs, it will be cp logo.gif to the backup dir, and logo.gif has been backed up. So you can see there's a substitution going on here. It's almost like there's an explicit variable assignment taking place. It's almost like someone's going 1 equals report.txt, and then the second time 1 equals logo.gif, and then we'd obviously be treating 1 as the name of a variable so that we can use $1 to extract the contents of that variable. That's kind of what is happening under the bonnet, but we can't actually see that happening. Okay, so let's have some more information about that. There are actually 9 possible parameters that can be individually referenced for any one function. You can actually specify as many parameters as you like to a given function, but you can only reference the first 9 of them individually, and of course you do that by using $1 to $9. We will see in a later chapter how to actually access the ones beyond that individually. There is a way, but it's a little tricky. You can get to the 10th, 11th and 12th variables and so on. And we'll also learn in just a moment how to access all the variables, all the parameters collectively. But I want you to note, before we do that unlike many programming languages like C or Pascal or so on, there's actually no reference to a function's parameters on that function's declaration line. Now, if you're not a programmer, you won't know what that means, and that doesn't matter. You can kind of ignore that. But if you are a programmer, you may be used to seeing on the very first line of the function some indication about how many parameters the function takes, and even perhaps what type those function parameters ought to be. And well, I'm here to say that you don't get that in the shell. There is simply no parameter checking done whatsoever. You can call a function with as many parameters as you like. If that function is expecting 3 parameters and you only give it 1, well, it's your job to actually test how many parameters have been passed and to perhaps put out an error message if it's wrong. So I'll show you now how to do that. There are some handy shortcut variables that are created for us by the shell, and they are as follows. $* actually represents all the parameters that have been passed in on the command line, so you can do things with all the parameters at once if you need to. And there actually may be hundreds of them. That is possible. If, for example, the function was called with parameters being all the files in the current directory, and maybe a big directory. The second shortcut that we have available is $# or $pound. And that represents the number of parameters. For example, you might get 4 parameters. So you can actually use that in an if statement to determine whether you've been passed the correct number of parameters. It's very simple. You'd use that with test, so you'd say if test $# is greater than 3, or whatever it's supposed to be, then you can print out an error message or do whatever you like. And there's one final shortcut that's used with function parameters, which I'll now show you, and that is in conjunction with the for loop. It's actually useful to create a for loop that loops once through each parameter that the function receives on its command line. So the code looks like this. We have a function called backup these files, which we're going to assume takes several parameters on its command line, as you can see in the last line, where we're calling it with *.txt and *.doc. Now, incidentally, how many parameters is backup these files actually getting? How many parameters are there on the command line? Well, the answer is surprising. It is not 2. If you said 2, you'd be mistaken. Well, it's not necessarily 2, I should say. Let's say there were 5 files in that directory that ended in .txt, and there were, let's say, 6 that ended in .doc. Then backup these files, the function would actually receive 11 parameters, because what would happen would be the shell would process that command line first. The backup these files *.txt, *.doc command line would be processed by the shell first, who would do all the wildcard expansion, and so you would end up with 11 parameters to back up these files. Anyway, the key point about this is the very first line inside backup these files is for fname. Now remember, we're doing a for loop here, so what we expect to see is for fname in something. But the lovely shortcut that we have here is that we don't actually have to put in anything. We can just say for fname, and what it will do is it will loop through the code block, and each time fname will be assigned to the next command line parameter that the function received. So the first time through the loop, fname will be set to $1, and the second time through the loop, fname will be set to $2, and so on. And even if there's more than 9 parameters to the function, like in this case I just said there might be 11, it still works. So in this particular example, we would get 11 different copies followed by 11 echoes. If you really wanted to be explicit about the for loop, you could actually write for fname in $. Remember, $* represents all the parameters on the command line, so that would work as well, but it's just not necessary to put the in $* there at all. So let's have a look at that in action. So here's that same code, essentially written into a shell script. I've only made two modifications. One is I've actually copying them to the temp directory, and the second modification is I'm just going to back up the files that end in .dat. And there are in fact two files in this directory that end in .dat, names.dat and places.dat. So let's run it, back up, and I get names.dat has been backed up and places.dat has been backed up. So it would be fair to say that the for loop is actually looping through each of the parameters successfully on the command line. So you've just seen now how to pass information in to a function. This module I will show you how to get information back out of a function. And a function can return information to the calling environment in two different ways. The first is to use output. And I'm just talking about standard output. I'll go into that in more in a moment. And the second is by way of an exit status. Now you recall we've talked about exit statuses before when we've been using if statements and while loops. Well, now we're going to talk about them in conjunction with functions and how you can actually set an exit status for your function. But that's in a moment as well. First I want to talk about function output. So this is the first of those two options. It's actually fairly straightforward. The function output, the output the function produces, is actually just the combined output of all the programs run within the code block of the function. For example, the who program or ls or echo or any of those programs. If they produce output, then the function produces output. It's pretty much as simple as that. Now, typically this output will just go onto the screen, but you can actually get it to go somewhere else if you do this in the following way. Now these are all ways that you've seen before, just not in conjunction with functions. You could send the output of a function to another program, for example a filter like wc-l, just by piping it. So sample_func would be the name of a function, and theoretically that function would produce output. Of course you can also send it to a file. You can say sample_func redirected to file 1. And more interestingly, this is a slightly more clever option, we have the ability to take the output of that function and store it in a variable using the back quotes. Now we've seen this technique before, the back quotes technique, especially in conjunction with the EXPR program, if you recall. And it's just interesting to know that we can actually use exactly the same technique without any modifications at all in relation to functions. So I guess you can summarize this page by saying that functions behave just like any other Unix command. Now, also, every other Unix command produces an exit status, and functions are actually no exception. They produce exit statuses as well, even if you don't explicitly program your function to set one yourself. It works like this. If you do not specify an exit status for your function, then the exit status of the last command that your function executes will be used. So if the very last thing that your function does, for example, is an ls, then the exit status of the ls program will be the exit status of your function. Now, if you actually want to specify an exit status, you can. You must use the return statement in the following way. You simply say return and then a number, and that number will represent the exit status that you're trying to create, which of course will be typically 0 for no error, or 1 for some kind of error, or alternatively you can think of it as 0 being true and 1 being false. Make sure that you don't actually return true or false. There's an actual program called true and a program called false. You cannot actually say return space true or return space false. You cannot do that. I'll leave that as an exercise for you to work out why. You might actually like to try writing a little function in a shell script to do that and testing it and see what kind of messages that you get. So an example of a fully written function that uses the exit status facility using the return statement is the following. I've written a little function called validFile, whose sole purpose in life is to determine whether a given file, its parameter, its one and only parameter, is valid or not. So it will return 1 or 0. So let's have a look at it. The very first thing in the function is that we test to see whether the file is readable. So if it's not readable, then we return 1, which we can interpret as meaning false. Notice that no output is produced here. We are simply returning a exit status. So now if we made it past that first line, then it must have been readable. Let's test it to see if it contains the string log file. So if, theoretically, according to the logic of this little function, if the file contains the word log file, then it is a valid file. So what this will do is it will test to see whether grep actually finds the word log file in it, and if it doesn't, it will return 1. And if we successfully make it past that line, then grep must have found log file in the file, so we can safely return 0. Notice that no output is produced at any time, not even via the grep, because I've redirected the grep output to /dev/null. So this little valid file function can be used in the following way. We can say if valid file and then specify the file name that we want to test. So then we can read that as saying if maid21.log is a valid file, then and do some particular processing there. Now there's one thing that we actually need to keep in mind when using the return statement, and that is that it's actually similar to the exit statement. Now we've used exit before. We've used exit just on the regular shell command line, and we've probably also used it inside a shell script. They're similar, but they should not be confused. Here's the difference. The return statement actually terminates the execution of the current function, and that's all, whereas the exit statement terminates the execution of the entire shell. Now if you've placed that in a shell script, then that means that typically the shell script will terminate and you'll be left back at your login shell. And whether you use return or exit, both of them take an optional parameter. That number represents the exit status that is returned to the calling environment. Now if it's a function, that represents the function's exit status, and if it's using exit, as in exit the whole shell script, then the number will represent the exit status of the entire shell script. So that's about it for exit statuses. It's actually not that hard. It does take a little bit of getting your head around it because it's an unusual concept, but it's not a difficult concept. So maybe have a little bit of a practice using that before we get to the chapter exercises in a couple of modules' time. If you spend a lot of time developing shell scripts, you'll end up at some point creating some code that you would like to reuse. And when I say reuse, I mean you might find that the code is so useful that it could be readily assimilated into other shell scripts that you're developing. Now, of course, it's possible just to simply, copy and paste the useful code from one script to another. But the trouble with that technique is that you then would end up with several copies of your very useful little piece of code. And if you ever decided to make an enhancement to your very useful piece of code, then you'd have to make that enhancement in many places. It's much more professional to actually write that piece of code once and then, if you like, include it wherever it's needed in other scripts. Now there is actually a sort of an include facility in shell scripts. It's actually the dot command. You may have seen the dot command before. It's actually another way that we can run shell scripts. In fact, I showed it to you at the beginning of this course. It causes the shell script to get executed using the current shell, as opposed to spawning a separate shell, as you recall. Well, that's only one use of the dot command. You can use exactly the same functionality within a shell script to, if you like, include other shell scripts, or at least other functions from other shell scripts, into the code that you've got. Let's have a look at how that might look. Now, I've included two script libraries here. I've called dot, and the parameter to dot the first time is script library 1. Now, script library 1 would theoretically contain, it could contain any shell script, and the code in that shell script would get executed immediately where the dot line is. But what's really handy is if script library 1 just happened to contain functions and functions only. Now in that situation, no code would get executed immediately, but all the functions available in script library 1 would then become available inside this shell script. So of course you could then call any function from script library 1. The same of course applies to script library 2. I've just thrown that in there to show you that you can actually include several files in the one script if you choose to. And then down the bottom I've made calls to two functions. One is called func from first library, and the second one's called func from second library. So theoretically I'm just calling a function from each of the two script libraries. I'll actually show you a worked example of this technique in the next module, which is a case study. So let's have a look. What I'm going to do now is try and tie all of this function information together into one very large and concrete example. I'm going to write a function called yes/no, and that function is going to take parameters on the command line. It's going to return an exit status. It's going to be a useful and meaningful function with reasonably sophisticated processing inside. It's going to be fully commented, and it's actually going to be placed into what I might call a function library and included into another shell script. So we'll tie all of that together now in this one module. So let's have a look at the specification for this yes/no function. I want a function that will do the following. Its parameters are going to be treated as the words of a yes/no style question to ask the user. For example, is your gender female? Or do you really wish to delete this file? Something that is a question of a yes/no style answer. Secondly, it will read an answer from the keyboard and check that the answer conforms to one of the following styles, and that is lowercase y, uppercase y, lowercase yes, or the same for n, no, anything basically that starts with a y or starts with an n. Now if they don't specify one of those answers, then it's going to essentially go back and ask the question again until they answer a yes or a no. So finally they will have hopefully answered a yes or a no. The function will return an exit status of true, or 0 of course, if they answered yes, or an exit status of 1, which we'll interpret as false if they answered no. And then you might use the function in the following way. You could simply say, if yes, no, do you really wish to quit now? And then if they answer yes to that, then the function will return true, which means the if statement will succeed, which means the exit will run. So essentially if they answer yes, then the shell script will exit. So let's have a look at that now. Here is my yes/no function, fully commented, and I've put it inside a file called func library. And I have made this file available to you all on the CD. Just look in the Chapter 8 folder. So let's have a look at the actual code. Here is the starting line of the function. There's the round brackets and the opening brace. Now obviously there's going to have to be a loop involved because we have to keep asking the question until they answer a valid answer. Now here I could have written while true. I could have put that like that because I want this to be a forever loop, because that's the style of programming that I prefer. But it's actually just equivalent to put while colon. Colon is also a Unix program, just like true, that returns an exit status of 0 always. And also it does nothing, which is very handy. Okay, so that's essentially saying while true, and then the very first thing I'm going to display on the output line is the parameters that they passed in. So the question will be the $. That will be all the words that make up the question. Now after all the words I'm going to put yes or no, and then a question mark, and then a space, and then I'm going to pause right there. I'm not going to go on to the next line. We're going to suppress the new line on the end of the echo statement, and then we're going to go and read the answer. So we'll read the answer, and the answer will be stored in yn, the yes, no. Now it may not be yes, no, they may not type anything at all. But we'll actually only store the first word of their answer in that little variable called yn, and the other variable called chunk will get the rest of their answer in case they happen to type many words of an answer. Then we think of all the different ways that they could type in yes, lowercase, uppercase, capital case, and so on. So if they did actually type one of those versions of yes, then we will return 0, which we will interpret, of course, as true. Now we essentially do the same thing for no, where we return 1. Now if they returned anything else, which is the star option for the case statement, then we'll echo out, please enter yes or no. So the question is, what should we do then? Well, the answer is we just go around the loop again. So we'll just say here, continue around the loop, even though we don't actually have to put the word continue, because what's going to happen is the very next line is the end of the loop, which will mean we'll just go right back around the loop again. We'll go right back to here and do the echo statement again, and we'll just keep going around and around until we either get to this return or this return. So I guess you can summarize that by saying there's only two ways out of this function, and that's via that line or that line. And you can only get to that line or that line if you enter a valid response. Otherwise we loop indefinitely. And that's it. That's the whole function. Notice the use of the exit status here and here. But that's only half the picture. What I'd like to do now is actually show you how you might use the yes/no function. So what I'll do is I'll open up the other file, which is called test yes/no, and you can see that what it does is it dots the function library. So what that essentially does is it includes all the lines from the file called function library as if they were part of this file called test yes/no, which means of course that all the functions in that file called func library are available in this shell script. And this shell script of course is a very simple script. It's just a while true loop, so it just loops and loops and loops, and every time it says if they answer this particular question in a true way, then we'll exit. So what will happen is we'll continue going around this loop while the yes/no function continues to return false. Because if yes/no returns false, then we don't exit. We simply come down to here and go around the loop again. So let's test this and see if it's working. And we'll do it like this. Do you really wish to quit now? Now let's enter some garbage response. Please answer yes or no. And I just pressed enter there with no answer at all. And I could say, no, I don't wish to quit. Do you really wish to quit? Yes. And it quits, which I guess is what's supposed to happen. So as I said, I'll include both of those scripts on the CD so that you can have a little play with both of them. They are both very good examples of the use of functions. Okay, so that concludes the case study. All that's left now in this chapter are the exercises. Here are the exercises for Chapter 8. First, we have a simple script that will contain one function. That function will calculate the average of all of its parameters, and it will print that average to standard output, so essentially it will just echo it if it needs to. So parameter, then obviously the average will be that parameter. Hopefully all these parameters are going to be integers. In other words, it's not really meaningful to average car, banana and umbrella. We can only obviously average numbers like 17, 301 and -6. So your program can actually assume that. It can assume that all the numbers that it gets are actually integers. But the interesting part about this exercise is there could be many numbers specified on the command line. There could be 1 or there could be 100. In fact, there could even be 0. So I want you to make sure that you handle the case where no parameters at all are given. You can, if you like, treat the average of no numbers at all as just 0. So if they don't supply any parameters, then you can just echo out 0. If they do specify parameters, then obviously you have to add them all up, divide by the number of parameters there were, and that will give you the average. And all you have to do is make sure that that average ends up on the screen. Now that's actually a moderately difficult exercise. It requires a good understanding of function parameters in order to solve that one successfully. Next, we modify the course project. We're basically just going to introduce a bunch of functions into our course project. We're going to take our existing code, which is at the moment just in one big long stream of code, and we're going to break it up into smaller chunks, which is a very professional way of writing a large-scale project. Rather than having one great big main set of code, which is say 300 lines long, you have a series of smaller chunks, and each chunk is a function. So anyway, we're going to do that. We're going to make sure that the code block that gets executed for each menu option is actually a function. So we'll have, I think we've got 4 menu options at the moment. 2 of them don't actually do anything. So we're actually going to create 4 functions. One that will do the creating, one that will do the viewing, one that will do the searching, and one that will do the deleting. I actually want you to create 4 functions, even for the 2 that have not been implemented yet. You can just, the function, all it needs to do is echo out back to the screen again, this is not implemented yet, or something like that. So we'll have 4 functions there. Now also I'd like you to copy and paste the yes/no function into your script. If you like, you can include it using the dot operator, I don't mind, but the solution will actually show it included in the script. And then once you've got it in there, I'd like you to use it to ask the following questions to the user. When they type Q to exit the program, I want you to ask them if they're sure that they want to quit. I want you to check every addition of a record. So when they go about adding a record, once they've typed in all the details of that record, I want you to show them what they've just typed in and ask them the question, something like, are you sure this is what you want to add to the database? Which will give them a chance to back out of that if they have a typo. And if they say no, then obviously just go around again and ask them all the same questions again about surname, first name, street address, and so on. And thirdly, after they add one record, without leaving that function, without leaving the adding a record function, ask them if they'd like to add another one. So the add record function will really be an add records function, because they may actually add several records. So as soon as they've successfully added one, we will get them to add another one. We'll ask them if they'd like to add another one, and so on until they say no, they don't want to add any more. And finally, the pause function. You remember I showed you a pause function earlier on in the chapter. I'd like you to create your own pause function, add it to the project, and call it simply once at the end of the menu options. So once they've run one of the menu option functions, to add, view, search, or delete, then we can call the pause function to simply pause at that point, before we go around the loop again and show them the rest of the menu again. Okay, so there's quite a few modifications there. None of them is particularly difficult, but there are quite a few of them. So good luck with that, and I'll see you in the solution. Here are the solutions to the exercises in Chapter 8. Firstly, the average function. Okay, so here's the start of the function. Now the very first thing we have to do is test whether they supplied any parameters at all. Now the easiest way to do that is test whether $hash or $pound is equal to 0. And if it is equal to 0, then we can simply echo out 0, that's being our made up answer for the average of no numbers at all, and then return. Now if we made it past here, then they must have supplied some parameters at all. So let's set up a variable into which we're going to accumulate the total of all the numbers, because remember the average is the total of all the numbers divided by how many numbers there are. And then we'll use a for loop to run through each of the parameters that they have supplied. Remember that that is actually short for writing that, and we're not going to actually do that because we don't need to, but that's what it would be. So this will loop once through each of the parameters, and the variable I will take the value $1, and then it will take the value $2, and so on through each one. And then we use expr to add that parameter into the total. And then of course we put the value back in there into total. So once we go through that entire loop, the variable called total will contain the sum of all the command line parameters. So then all we have to do is call expr and ask it for the sum divided by how many numbers there actually were. And no echoing is actually necessary, because the expr program will indeed echo that information out itself to the screen. And then I'm just going to test it here. Notice the use of the back quotes here, average of 4, 8 and 21, and then we'll just do 3 different ones. Notice the third one will test the case where we don't specify any parameters at all. So let's run that and find out. It should work. The average of 4, 8 and 21 is 11, and that is correct if you do your mental arithmetic. And the second one, the average of 4 and 14 is 9. Well, that's pretty obvious. And then the average of nothing is 0. So that case is working as well. How did you go? Well, it is a reasonably tricky one because you do have to have a fairly good understanding of function parameters. You have to be able to use the $hash. You have to be able to use this for loop construct. And of course you have to be able to sum some variables. So there's a fair bit to it. The course project is actually slightly easier in terms of understanding, but there's a bit more work involved. So let's go and have a look at that now. So let's have a look at the changes now to the contacts database program. Here's a little pause function. Now you've seen the pause function already, so I've just copied and pasted it in here. Then we have the yes/no function, which again you've already seen before, so I'll just scroll all the way over that. Now we have the create function, which will create records for our database. Now remember, I actually was modifying, I asked you to modify the functionality of the creation process because I want two questions to be asked. The first is, after they enter some details about a record, I want you to confirm with them that the details that they entered are correct. And once we finally make it through that, you need to ask them another question as to whether they wish to enter any more records. So it sounds like we're actually going to need two loops, a loop within a loop. So let's have a look at that. So we'll loop until the user is sick of entering records, and then an inner loop, we're going to loop until the user is satisfied with one individual record. So now we're going to read in the contact details from the keyboard. Please enter the following details, and then confirm. And it's the confirm part that's actually new. So we can tell them, you've entered the following contact details, and all that's fairly straightforward. And then ask them if these details are correct using the yes/no function. So here we go. Are these details correct? Now if they answer yes to that, then we can simply write those details out to the file and break. Otherwise, well, we hit the done, which is the bottom of the loop. It's the bottom of the inner loop, so we go back to, where is it? Here again, and ask them to re-enter the details again. So we keep going around here until they say that these details are correct, at which point we break out and we get down to here. So we've successfully entered a record. Now we ask them if they want to enter another record. So we say, do you want to create another record? And if they say no, or in other words, if this yes/no program returns false, then we will break out of the outer loop. So that's reasonably sophisticated in the sense that there is a loop within a loop. But that's the only really tricky part about it. Next we have the do view part, which will just view the contents of the file, which is fairly straightforward. It's just the code that we had before put inside a function. And we've seen all that before. And then the search function does actually nothing at all except a simple echo, the same with the delete function. And then we finally get down to the main code. Now this bit we've already seen before, and we've seen this before as well. And finally, the only difference is when we get to these parts here. Now this code is now looking very simple because we either do a do create, a do view, a do search, or a do delete, and that's all we do. And then notice the queue options. Do you really wish to exit is the question that we ask. We feed that to the yes/no program, and if they return yes, then we exit. Now if they don't return yes, then we don't do anything at all. So in other words, we drop out of the end of the case statement, do our little pause, which is the new thing that we just added, and then go back around the loop again. So it's there's a lot of new code there, but it's not particularly tricky. It will be new to you, very new to you, if you've never used functions before, but if you have used functions before, it should be fairly obvious how it's all working. If it's not obvious, then I suggest that you spend some time examining the code, go back and look at all the examples that I described for you and some of the case studies and exercises that we did earlier, and keep studying it until you actually fully understand it, because it has been fully explained. Good luck with that, and I will see you in the next chapter.